Hello, in this lesson we will learn how we can use the lock method that is provided by the threading library and see how we can use it among multi-threaded classes. Okay, so the lock method is used in a situation where more than one threads are sharing the same resource and we don't want any accident to happen. For example, if two methods are sharing the same variable as a parameter, as an argument, but one of these methods may write a different value to that variable. We want this method to finish first before the other ones can read the new value. We don't want the other methods to accidentally read the old and previous value of this variable. Okay, so let's start by giving an example. So first of all, we want to import threading, and then let's say lock equals threading dot lock. Okay, so now we just created a new lock. Now if Lock.acquire print lock acquired successfully. Okay, so if we run this, we can see that we get this as an output. So what happens is this statement returns true and the lock is now locked. So when we first created the lock, it's by default unlocked, and by using Lock.acquire we can lock the lock. So now let's see what would happen if we would say if Lock.acquire again. We could print lock acquired again. So we can see that the program never finishes executing, and we can see it gets stuck because it's now waiting for us to unlock it. So if we could go here and add Lock.release, now if we stop the program and rerun it, we can see that we released the lock, and here we just locked it again. So we can return lock acquired again. Okay, so this is a very basic example on how to use locks. So now let's take a look at the more complicated one. So first of all, let's import time and threading. Now let's create a new lock, threading.lock. Okay. So now let's create a new class called foo1, and let's give it a parameter of threading.thread. Now let's create a global variable called lock, and let's define a run function. Okay, so while true, so let's make an infinite loop, we can print foo1 trying to acquire lock. Okay, so let's leave a new line as well. Now if lock.acquire, we can print foo1 acquired lock successfully. Leave another line. Okay, so we can exit the if loop, and now we can just set foo1 is sleeping for 5 seconds and time.sleep for 5 seconds, just like we said. And after 5 seconds we can release the lock, so lock.release. Now print foo1 has released lock successfully. Perfect. And now, just in order to break this loop, we can return false. Okay, so this is our first class, foo1, that just in its run function it will run while true. It will try to acquire a lock. If the lock is acquired successfully, it will print this message, then it will sleep for 5 seconds. After the 5-second delay, it will release the lock and it will print foo1 has released the lock successfully, and this will keep happening. We can return false here and exit the loop. Okay, so now let's create another class, foo2. We can also give this a thread as an argument. Let's create again a global lock, and let's define the run function. While true, we can just actually we can go ahead and copy this. Okay, so now just change these to foo2. Okay, so now we can go ahead and say if name equals main, foo1 equals foo1. So let's create a new object, foo2 equals foo2, another object, and we can start these. foo1.start and foo2.start. So this will just run the run method inside of the class, if you remember. So let's go ahead and run this and see what happens. So we can see that we're trying to acquire the lock. We acquired the lock successfully. Now we're sleeping for 5 seconds. foo2 is trying to acquire the lock, and now you can see at the same time we have released the lock successfully for both of these after 5 seconds. And then we released the lock successfully for foo1, and then after foo1 is done, we acquire the lock for the foo2 method. Then the foo2 is sleeping for 5 seconds, and then we release the lock successfully. Okay, so as you can see, first of all, the run method inside foo1 runs, and then after it's finished, then the run method inside foo2 runs. But now let's make a little modification. We can go ahead and say, okay, inside of the run function we can define a counter which will be equal to 0, and we can say while counter is less than 3, and instead of returning false here, we can just say counter plus equals 1, and we can do the same here. Let's define a counter equal to 0, and instead of returning false, counter plus equals 1. Okay, so this will run each of them 3 times. Okay, so now let's let's give this more space here, the sleeping time, and instead of 5 we can do 1 second here, and we can also remove this printing statement as well. Let's add new lines at the end of everything just to make it more clear. Yeah, these two can go. And just to make it more clear, we can also remove the printing the sleeping time. Okay, so now we can go ahead and run this. So you can see we acquire the first lock. After 1 second we release it, and we do this again for 2 times. So what happens is we acquire the lock as the first function runs. When we release the lock, we can see that the foo2 acquires the lock, and when foo2 releases the lock, it is acquired again by foo1. So that goes back and forth until both of them are finished. So this is how the lock works. Okay, so when we release the lock, we can then acquire it for another method, and then we can release it as long as we're done, and then we can acquire it as another method. Okay, but this example works for a specific time, so we know that this loop is going to run 3 times, as well as this one. But what happens if more randomness is used in the program? How well does lock handle that? So let's take a look at another example. So in this example, we will create a producer that produces data, and we will add this data to the queue, and the consumer will remove this data from the queue. So let's see how this will work. So let's go ahead and import time and also threading, and from collections we can import the queue. So we can create a new queue. This is how we can declare a new queue, and queue has 2 different methods that we can add things or remove things, and it works just like a list. So we can do queue.append to add something, and queue.pop to remove something from the queue. Okay, so now let's create a new class called producer, and give it as a parameter Threading.thread. Now let's define the run function. We can create the global queue. Now the counter will be set to 0, and let's say while counter is less than 10, queue.append, and let's create a random rand int. So let's create a random integer from 1 to 10. Now let's print data appended for the queue will be our queue. And now let's do time.sleep for a random time between 1 and 10 seconds. And after that we can just do counter plus equals 1 to increment the counter. Okay, so now let's go ahead and run this. If name main, let's create a new producer object. Great, and let's start this so we can do the running. We can run the run method. Okay, so let's run this. Okay, so we can see data appended, and we can see that it appends data, and it sleeps for a random time between 1 and 10 seconds. I'll just wait for this to finish. Okay, so our program has finished, and we can see that it has created a queue and has added one by one until it reached the 10 elements that we wanted. So now let's change this program a bit. So let's give this here 10 elements. Okay, and now inside here we can just do we can just delete this. We can do queue.pop to remove one element. So this will be our actually let's leave this as it is, and we can create the consumer class. So under here, class consumer that takes as an argument threading.thread. Now let's define the run method inside here to create a new thread. Now global q, the counter will be set to 0. Now while the counter is less than 10, we can just do q.pop and print data removed from the queue, which will now be this. Now let's do time.sleep for random.randint 1 between 1 and 10. Now let's increment our counter by 1. Now let's create the consumer and see how this runs. So c equals consumer. Let's create a new consumer object and c.start. Actually here we need to put these inside of square brackets. Okay, so we can see that it removed one element. Now it is waiting for a random time between 1 and 10, and there it goes, it just deleted another one. I will let this run. Okay, so as you can see, it removed each element one by one 10 times until there is nothing left. So we gave example for both the producer class and the consumer class. So now let's go ahead and create both a consumer and a producer. So p equals producer. Now let's just make these both start. Let's start the producer first. And also just remove everything from the queue. So it starts with 0 elements. But let's run this. Okay, so you can see here we created something. We created one element and then removed it. Now a second one, third one, another one, let's wait. So there is our problem. So what happened was, because the times are random, we had something created, but then it got immediately removed. And before we had the chance to create and add to the queue another item, the consumer tried to remove it, but the queue was empty, so we got this error. So let's see how the locking mechanism can solve this problem. So let's just create a lock here. Let's stop this program as well. Let's create a lock here. Threading.Lock. And now what we can do is inside here, inside of the producer, we can say if Lock.acquire, then we are free to do all of these things if we can acquire the lock. So after here we can just release the lock, and the same goes for the consumer. So if Lock.acquire, and then we can do Lock.release. So I can execute this, and you can see that we no longer get this error, because in order for the consumer to try to remove something, we must first have added that something. So this problem now doesn't exist. So I will let this run and finish, and I'll get back to you with the result. Okay, so now the program has finished, and we can see that we created all of the elements that we needed, and then we removed all of the elements again. So this works, but the problem is it defeats the whole purpose of the asynchronous programming. So we have to wait for the first one to finish, and then we start removing the elements. So what we would ideally do is just create something and then remove it as soon as we can. So we can do this by using another kind of lock. So we can go up here, and instead of threading.lock, we can do threading.condition. And inside of our run method, we can do lock.notify. And same goes for our consumer. So we have to go to the consumer. We'll just leave this as Lock.acquire. Let's set this back once. Okay. And now we can just say under acquire if not queue. So if our queue is empty, we can just say waiting for producer to put items in queue. So if it's empty, we won't attempt to empty this, and then wait. Now we can print producer has put something in queue, and then we can leave the rest as is. Now let's go ahead and run this, and I will get back to you as soon as it's finished. Actually, I forgot to remove this here, so we don't have to do if lock acquired. We can just do lock acquired, and let's remove the indentation here, rerun this, and let's also add the global lock to both of these. Is there anything else I forgot? Okay, so the problem is we need to add these before the sleeping time, and we also need to add a Lock.release here, which I also forgot. Now let's run this, and it should work fine. So you can see we append 5 to the queue, then we remove 5. Oh yeah, the problem is I did not remove this statement. Okay, now it's fine, now it should work. Okay, let's just give it a chance to return the error, just so you can see it works fine now and it won't give you an error. Okay, so the point is this will run fine. This will not cause any problems, just because we used the other kind of lock that can give the notification that it's done. Now we can continue. And the way this works is it can wait until it gets the notification that the lock is released, and now it can still continue. Okay, so that was it. Try to practice with locks. It's a bit of a complicated subject. It's not easy to get it right for the first time. You may need to do some trial and error, just like I did. A problem might arise. Maybe you didn't think of releasing the lock earlier, or maybe you tried to acquire it in 2 separate occasions. So just run your program, see how it reacts to different inputs, and modify your code just so it runs for the best time, for the less time as possible, but it also doesn't cause any problems or doesn't read or write to any variables by accident. Just like we tried to remove items from the queue while the queue was empty. Okay, so that was it. See you on the next lesson.